Imagine waking up one day and realizing Earth is no longer safe, not centuries from now, not in science fiction, but within our lifetime. Climate instability, asteroid threats, global conflict, or resource collapse. Humanity has faced extinction-level risks before, and history shows they are not impossible. If we ever had to leave Earth, even temporarily, there is one question that matters more than any other. Where could we actually go? When scientists seriously examine this question, the answer is surprisingly clear. Not Venus, not Jupiter, not Saturn, not even the Moon. There is only one planet in our solar system that humans could realistically live on in the near future. That planet is Mars. Living on another planet is not about planting a flag or surviving a few days. True survival means staying alive long-term. It means building homes, growing food, producing oxygen, managing health, and raising future generations. For that to happen, humans need several non-negotiable conditions. A solid surface to live on, gravity that won't destroy the human body, access to water, a day-night cycle compatible with our biology, raw materials to build shelter, generate energy, and create fuel. When every planet is evaluated using these criteria, Mars stands alone. Take Venus, for example. From a distance, it looks similar to Earth, but the reality is brutal. Surface temperatures reach nearly 500 degrees Celsius, hot enough to melt lead. Atmospheric pressure is 90 times stronger than Earth's. Acidic clouds rain sulfuric acid from the sky. No human technology exists that could support long-term survival on Venus's surface. Mercury is just as extreme, with temperatures swinging from freezing cold to scorching heat and no atmosphere to protect against radiation. The gas giants, like Jupiter and Saturn, don't even have solid surfaces. And while some moons like Europa or Titan are scientifically fascinating, they are far away, difficult to reach, and surrounded by lethal radiation or extreme cold. Mars, by comparison, is harsh, but manageable. Mars is a rocky planet, much like Earth. It has mountains taller than Everest, massive volcanoes, deep valleys, and vast plains. Humans can walk on Mars, drive vehicles, mine the ground, and build permanent structures. This may sound basic, but it immediately eliminates most of the solar system. Mars is the only planet besides Earth where humans can physically live on the surface rather than floating, sinking, or being crushed. Gravity is another critical factor. Mars has about 38% of Earth's gravity. That may seem low, but it is far better than the Moon's 16%. In microgravity, or very low gravity, the human body rapidly deteriorates. Bones weaken, muscles shrink, and organs change function. While Mars' gravity is not perfect, scientists believe it is strong enough to significantly reduce these problems, making long-term habitation far more realistic than anywhere else beyond Earth. Then there is water, the foundation of life. For many years, Mars was thought to be completely dry. We now know that isn't true. Mars has vast amounts of water ice beneath its surface, especially near the poles, but also in mid-latitude regions. There is overwhelming evidence that Mars once had rivers, lakes, and even oceans. This water didn't disappear. It froze or sank underground. Water on Mars would be used for drinking, growing food, producing oxygen, and even creating rocket fuel. Split water into hydrogen and oxygen, and you get breathable air and propellant. Water turns Mars from a dead rock into a planet with potential. Mars also offers something incredibly rare, the ability to make oxygen and fuel directly from its atmosphere. The Martian atmosphere is mostly carbon dioxide. On Earth, that would be a problem. On Mars, it's an opportunity. NASA has already tested a device called MOXIE, which successfully converted Martian carbon dioxide into oxygen. This proves that future astronauts won't need to bring all their air from Earth. They can make it there. This capability changes everything. It means Mars missions don't have to be one-way trips. It means fuel for return journeys can be produced on site. It means settlements can slowly become more independent instead of relying entirely on Earth. Mars also has something surprisingly important for human psychology, a familiar day. One day on Mars lasts 24 hours and 39 minutes. That's almost identical to Earth's day. Human bodies evolved around this rhythm. Sleep cycles, hormone production, mental health, and productivity all depend on it. On planets where days last months or years, long-term human life becomes psychologically unstable. On Mars, the sun rises and sets in a way that feels natural. Yes, Mars is cold. The average temperature is around minus 60 degrees Celsius, but temperatures near the equator can rise above freezing during the day. More importantly, cold is a solvable problem. Humans already live in Antarctica, where temperatures can be just as brutal. With insulated habitats, underground living spaces, nuclear or solar heating, and proper engineering, Mars's cold becomes a challenge, not a barrier. Radiation is another serious concern. Mars lacks a strong magnetic field and has a thin atmosphere, which means higher exposure to cosmic radiation. But again, this problem has solutions. Living underground, covering habitats with Martian soil, and using water as radiation shielding can dramatically reduce exposure. These solutions are difficult, but they are possible with technology we already understand. Mars is also rich in raw materials. Its soil contains iron, aluminum, silicon, and magnesium. These elements can be used to 3D print buildings, create tools, manufacture glass, and build solar panels. Instead of shipping everything from Earth, future settlers could build much of what they need using Martian resources. This concept, known as in situ resource utilization, is essential for survival beyond Earth, and Mars is the best place to apply it. Distance matters too. Mars is far, but not impossibly far. A journey takes about 6 to 9 months with current technology. Communication delays range from a few minutes to about 20 minutes. That's manageable. It allows for coordination, guidance, and emergency planning. Anything farther, like the outer planets or distant moons, becomes logistically overwhelming. Mars also offers something no other planet does: the possibility of terraforming. Not tomorrow, not next decade, but eventually. Mars already has carbon dioxide, water ice, and seasonal cycles. Some scientists believe that releasing trapped greenhouse gases could thicken the atmosphere and raise temperatures. Even partial terraforming could make Mars warmer, increase air pressure, and reduce radiation exposure. No other planet in our solar system comes close to this level of potential transformation. This is why Mars isn't just a destination. It's a strategy, a backup world, a second home for humanity. It's where we learn how to survive beyond Earth, how to build closed ecosystems, how to govern off-world societies, and how to protect our species from total extinction. Mars will never be easy. It is dangerous, isolated, and unforgiving. But when compared to every other planet we know, Mars is the only place where humans can realistically live using near-future technology. Not comfortably, not effortlessly, but sustainably. If humanity ever becomes a multi-planet species, history will remember Mars as the first step. Not because it was perfect, but because it was possible. And that makes all the difference.